In this lecture, we'll be talking about the graphs. So basically, let's have a look at what is graph. Whenever you are talking about a graph, one thing that comes in your mind is the x-axis and the y-axis, including the quadrants. For instance, let me take a review that how quadrants are divided. So basically, this is called the y-axis and this is called the x-axis. Basically, in the first quadrant, all the things, including the x-axis, is positive. Y-axis is also positive. In the second quadrant, the y becomes negative and x is positive. In the third quadrant, both of the situations are negative. And in the fourth quadrant, the x is positive and y is negative. Basically, graphs are visuals that shows a relationship between the intended to display the data way that is easy to understand and remember. Just suppose a person is moving from the initial velocity and he goes to here at the final velocity. Now this will be shown as a graph that this person moved upwards like this, and this makes a graph like this, and our final answer is something like this. So this makes the data easier to be visualized. So that's the only reason we use graphs. Graphs are also divided in these sections, like here you can have a look that this is called the origin, where the both everything is zero. That basically is the intersecting point for the x-axis and the y-axis. Now this is unlimited. It doesn't have any limit that the graph will be up to 10 or up to 20. It is limitless as the number are limitless. So when we are talking about the graph, so just suppose that I'm talking about the velocity. So velocity is equal to displacement upon time. We are showing a displacement in time where the time will be written here and the displacement will be written here. Now basically how we can guess that on which thing the velocity is dependent or velocity is not dependent. For that, let's have a look then. Basically, when we talk about the making or creating a graph, so there is an intention to make a slope. What is the slope? Slope is basically the thing that we made after the interception. Or if we talk about the formal definition for a slope, so it is the rate of change of one variable to respect to another. Like we talk about the displacement, so whether at the 6 points or something, so basically it's 7. So 7 seconds were took by a body to cover the displacement of 7.9 maybe. So this is called the slope. Slope can be whether straight, whether can be curved, so that is dependent. If we talk about a straight line, so it will be something like this. Apart from all this discussion, let's talk about the dependent and independent variables. So anything that comes at the x-axis is called independent variable. It is whether called the predator, explanatory, or input variables. If we talk about the dependent variables, so dependent variables are often called response, outcome, or output. So this was all about the x-axis and y-axis. Now let's move on to the base thing. So here just suppose that we are given a graph that consists of x-axis and y-axis. We have done some sort of calculation. So here these are the calculation that I have plotted. Now I have to make an assumption to make an average thing. Or what if I say that I have to take an average of these all things, or I have to take the best thing that fits this graph. So what will I do? Basically, in that condition, I will make a best fit line graph. What is a best fit line graph? It is a type of a graph that is used to visualize the relationship between two variables and is used to show the general trend in the data. The line of the best fit is straight and that is drawn in a way that it best represents the underlying pattern in the data. As you can see here, the most probably these two variables were intercepting in a straight line. So I have made a straight line where most of the variables are closest. This is the first rule to make the best fit line. And after that, I will calculate what I have been given by using the average formula and I'll be done with the accurate value. This is how we do that. Apart from that, what if we are given uncertainties and we have to plot that? So basically what we're going to do, first we have given this uncertainty. So I will plot this uncertainty. And then the second uncertainty. So here the uncertainties are being plotted. Now this neither makes sense, neither it does makes the proper fit line graph, neither it makes anything. So what is these kind of things called? This type of graphs are called error bar. What is an error bar? Error bar are graphical representation of uncertainties or variability in a set of data points. They are often used in scientific plot to indicate the precision of the data being plotted as shown. Now the error bar are usually plotted as a vertical or horizontal lines. Here you can see that I have plotted in vertical and horizontal lines. Now this extending from the data points on a graph. Now the length of the error indicates the degree. Like if I plot here the just suppose that I am joining these uncertainty, what I will do, I will make a line that indicates that this is a uncertainty. Now to calculate the uncertainty, what I will do, I will join these uncertainties. Not in this kind, that was a mistake. In a straight line, I will join this. Now this is called the uncertainty when they are joined. Now what if we are given that this is also uncertainty, this is also uncertainty, and we will make a graph, and this will be a long graph. So this basically indicates that there is shorter error bars and there are greater precisions, while longer error bar indicates the less precisions. Now error bars are useful in indicating the reliability and accuracy of the data, and they allow the reader to access the significance of the result. As we are talking about the uncertainty, so in the graphical system, the uncertainty can be removed like this. If we are done with this lecture, and thank you so much for watching this video.